Good afternoon, Math Dragons, and welcome to today's notes. Yesterday we worked on notes for calculating the area of parallelogram. We did a little decomposition and recomposition of the shape to prove how the formula for the area of a parallelogram basically is a breakdown of the formula for the area of a rectangle. We also investigated how to find the height and the base. Now we want to move on to some practice problems. So I'm on page 88. And I'm going to zoom in and allow you to copy the problems. I did not use anything typed out because I know not everybody has a printer. I do have graph paper as my background. So if you have graph paper, go ahead and grab it now. It would be a little easier to draw the shapes, but you can still have success without the graph paper. Okay, Dragons. Here we've got the top half. Go ahead and pause your video and copy the problems. Once you have them copied, unpause it as I go through the solutions with you. Okay, so hopefully you took an opportunity to copy those problems, and now let's fill them in. So I've really broke it down to a step-by-step process to make it as easy and painless as possible. Practice calculating the area of parallelograms. I can, and it's just like yesterday, decompose and compose parallelograms into rectangles in order to calculate their area. So we can chop them up if we need to. It's not absolutely mandatory, but we can chop them up. For example, I can take this section here and slice it, because they already gave me a situation where the vertex flowed down to the ground. It gives me a nice slice, and this can be shifted to this spot here. This is how the recomposition would occur. And that would just fill in here. And you would be able to imagine that now the new shape exists here. And that might help you visualize where the height and base exist. This might be good for you. Now the base is it can be any of the sides, but I try to make good choices here. I saw the 8, it's nice and flat. It's really quite easy. When it's flat, I try to choose it as the base. Let's see, I think yesterday base was green. Okay, so base is green. So I'm going to make 8 the base. Nice and flat. Now you've got to remember the one rule. The height and base must be perpendicular to one another. Perpendicular means it creates a 90-degree angle. What's convenient for us is it was already drawn into the diagram. So 4 miles was meeting 8 miles at a beautiful 90-degree angle right there. So 4 miles is actually your height, which yesterday was in orange. So I'm going to stick with orange. So starting to fill things in. The base, 8 miles. The height, 4 miles. I don't need the slanty. I call him the slanty. It's not a real term, but I hope you can see why we don't need him. If I recompose the shape, and the new shape is really this like outline here. You can see that that 5 would never be a part of the rectangle, not a true part of it. I hope that helps you see why the slanted side there isn't your height nor your base. So this is not somebody we need. We don't need that number. It's just extraneous. I'm going to go in with the orange right here to emphasize the height. There we go. So this guy's your base. This guy's your height. Color coding it for you. Okay, the formula, you might recall, is area equals base times height. Just B times H. So we like to go in and calculate it. Area equals base times height. Replace the value for base, replace the value for height. Our base comes in at 8 miles times the height, which is at 4 miles, You do 8 times 4, which is 32. You do miles times miles, which is miles squared. So your happy answer is area equals 32 miles squared. Beautiful. Next. Okay, we have another parallelogram here with a bunch of numbers that we may or may not need. The formula is unchanged. We are finding the area of a parallelogram, which is base times height. Now, the trick here is we have to find the base, we have to find the height. When I'm put in this position, I try to make the base the easiest one. I'm not a big fan of the slanted sides. They make me uncomfortable because I'm not sure that they're totally accurate. I like the flat sides. So to me, when I see this shape, I want to make 11 my base. He looks like he's on the ground. I'm okay with that. My next plan of action is which line on this shape is creating a 90-degree angle with the ground, with the base. Is 6.1 creating a 90-degree angle, or is 6 creating a 90-degree angle? This is not 90 degrees. This is a little bigger than 90 degrees. This guy looks perfect. So, the height is the one that comes down from the vertex and hits the ground, aka the base. The height is 6 miles. Need a moment to visualize this further? No problem. I can help you. Let's say we took this, chopped this off. We sliced this off. We go from the vertex to the ground, and we have this very, very skinny triangle here. We could slice him off, decompose the parallelogram, and then recompose it by sliding it over here. That sliver can fit here. If I do that, once I've sliced it off, I've got this, and this has become unchanged. This is kind of like my new side. And then this along the edge here is my new side. That might help you visualize, if this was a new rectangle, this makes sense to be the height. You're familiar with that because it's kind of like the length of the width of the rectangle. So yes, you can recompose it and make it work. Let's calculate the area together. Area equals base times height, which equals 11 miles times 6 miles. And you don't have to put a dot between the parentheses. It's rather optional. The two parentheses pressed up next to one another implies multiplication. So it's 11 times 6, which is 66, and miles times miles, which is miles squared. 66 miles squared. Happy answer. You're doing fantastic. All right, the next two are a little bit harder to draw too. So let me get those in focus for you. I put them on the grid paper and they are drawn to scale according to the grid. So take a moment, pause the video, copy down these shapes, maybe count the little squares, and then replay the video when you're ready for the solution set. Okay, so hopefully you got an opportunity to copy down those parallelograms. We're going to go through the 4-step process again. Here, I tried to make it slightly more challenging in the fact that I didn't provide any numbers, and we have to use the graph paper, the grid behind the parallelogram, to find the actual unit lengths. The first one, I'm not actually interested in decomposing and recomposing. He's not that simple. He doesn't line up that beautifully. But I can still find the base and the height. I have enough information according to the graph paper. Again, your base. Think of it as the ground. I really don't want it to be a slanted side. It's going to make my life harder. I'm going to choose a nice flat side. I like this side right here. This side is 1, 2. 2 units long. See? 1, 2. So we got 2 units here. Now I need something that is perpendicular to this new green line, aka the base. I could come from here and try to go straight down from the vertex. But customarily, that's not what we do. We tend to come to the outside. You'll see most drawings done to the outside. And what's happening there is they're extending the base in an imaginary sort of way. And they're taking this vertex, like the tip top of the mountain, and dropping down. And we're really just looking for the distance between this vertex and where the base would exist. 1, 2, 3, 4, 5, 6, 7. That kind of felt like Sesame Street. Okay, 7 units. Your base is not this whole long thing. Your base is only what occurs exactly on the shape. This part is kind of like an imaginary extension. But this distance is a real thing. That's because that distance could exist here. That distance could exist here if we wanted it to. But we chose the distance to exist here. So your height is that guy, 7 units. Let's get it in here, height. Your base is still this guy. Nothing's changed there. We are finding the area of a parallelogram. This is not a trick. The formula is still the same. So my base is 2 units long, highlighted here. My height is 7 units in altitude. We got right there, we got 7 units coming down from the vertex, hitting where the imaginary base extension exists. So we're going to go with area equals base times height. We've got 2 units times 7 units. 2 times 7 is 14. And then units times units is units squared. Notice that we never used the slanty side. We did not need to try to get clever and count this. We don't need the length of this side. He's not my base, he's not my height. If I needed the perimeter, that would be a whole different discussion, but they didn't ask me for the perimeter. Okay, next. And lastly, this shape here. I am looking for a side that lines up pretty against the graph paper. I am not interested in using the slant as my base. I could, but it'd be really hard to count because he's cutting sideways through squares. I would much rather use the flat side. So I'm interested in this side here. He's nice, he's flat, he's easy to count. I want to make him my base. 1, 2, 3, 4, 5 units. Now, I've been doing this a long time, so I can see where the height would fall. But that might be harder for you, and that's okay, because you're a beginner. So I think it'd be best maybe if we just turn the paper. If we turn the paper, I think you're going to be able to see where the height really is. So now I've made the parallelogram have its base towards the ground. Now think about it. We can find the height. I see 2 places we could use to find the height. I'd like to use one of the 2 top points. I can either come from here down, or I can come from here down. Either way, you're going to find a height. It can be inside the shape or outside the shape, but we're still finding the distance from the vertex down to the base where it's going to create a 90-degree angle. In this situation, on the outside of the shape, I would make my base extension, the imaginary extension. I'd come from my vertex and I would fall to the ground. I'm creating a 90-degree angle right there. But I could do the same thing right here. I could come to the vertex, fall all the way down to the ground, and create a 90-degree angle there. Lucky for us, either way, the count is the same. This is my height, or we could call this my height. It accomplishes the same thing. We're going to count that up. We got 1, 2, 3, 4 units. 1, 2, 3, 4 units. See, same thing. All right, so hopefully just spinning the paper a little made life a little easier. So now we're going to be able to go ahead and fill in everybody we need. Formula is unchanged. Base times height. The base was the 5 units. We identified the height as 4 units. We're going to do area equals base times height. Replace the base with 5 units. Now replace the height with 4 units. We're going to multiply those together. 5 times 4 is 20, and unit times unit is unit squared. It's pretty. That looks nice. Notice that I did not need the measurement of the slanty side. I don't need him, not for the area. So these two are a little more complicated because we had to use the graph paper for our measurements and we didn't have any lines indicated as our height. We had to make some really good educational choices here. Just want to point out here that this created a 90-degree angle as well. Let me go and finish highlighting any other notes. We got our base was this guy. Our height was this guy. If you have any questions about this, feel free to email me. Just let me know what you're referring to. And that should have you all wrapped up for practicing the area of a parallelogram. Thank you, Dragons. See you soon.